This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay, folks, we're recording now. I just closed the door. Okay, so today's lecture is going to be, you might have thought you were having a few fun and games with HPC, and now we're going to start throwing you straight into cloud. So the lecture today is going to cover a few things. I'll give the what is cloud, the sort of many flavors of cloud. Then we're going to get into some practical examples of using the cloud. So if you look on the LMS, under the resources section, I've created a folder which has got a bunch of crib sheets which you can follow. I flagged now that you won't be able to do all of those kind of things, and you won't be able to do all of the scripting, which Alpan's going to go on to later, until you log into the cloud, and then I add you to a team. So anyone who uses the cloud right now, you can log in using your Unimelb email address. So as usual, like with same as Orin, you know, it's using the Australian Access Federation using Shibboleth. We'll talk about the tech behind that later on. If you logged into the cloud now, you get a mini VM. You get a 4 gig virtual machine just for you to do stuff. Unless you've already used it in some other project or some other course, in which case chances are you wouldn't be able to access it again until we refresh it. One of the things that I need everyone to do, and I would suggest we do it during the lecture, is you have to log into the cloud. And because only once you've logged in once can I add you to a team. And so what I'm going to have, well, I and a bunch of the other techies are going to do, is everyone who's in a team here, I'm going to work out of the 370, however many we are now, students that are taking this class, whose name's in this list, whose name isn't in the list because they haven't added it to a team, and then I'm going to have to add other people into particular teams. So now's the time. I would suggest, for example, those two teams, without me being able to see any names, maybe you just want to sort of chat together and become a team of 5. Otherwise, I'm just going to put 2 random people into there and 3 random people into there. So you might want to self-organize before I just start topping you up with other students. And if you're that person on your own, find someone to play with and put yourself into a team. So again, I can do this for you if you don't know anyone. But ultimately, what I have to do, and this is really where it gets complicated, you might know your email address is that. Yo, folks. You might know your email address is that. You have to use the same email address that you would use for logging into Nectar. So I need that one. So if you're using an alias, so you might have 2 or 3 different email addresses at Unimelb. It's the one that you use to log into Nectar that should be in this spreadsheet, because that's the one I'm going to use to add you into a team. So team 1, whoever those people are, Ting Sheng. If you log in to into the cloud using that, then you're okay. If you're using something else, I won't be able to find you. I will not be able to add you to your team. So just double check that when you log in to the cloud, which you'll go into in a tick, use that, whatever it is that you used, make sure that's the same as the one here. Clear? Presumably so. Okay. All right. So this lecture is going to cover a few things. There is an optional thing at the end, which we're throwing in as well, which is Git. If you've never used code versioning systems or Git, for example, then we're going to teach you all about it, all the things you need to be able to do the second assignment when you're working as a team, effectively. If you've used Git for a bunch of years and you know all about it, you know all about how to commit and how to rebase and all the kind of different commands, then you don't need to attend that. But there's probably quite a few of you that have never touched it. Or even if you touched it, you might want to hang around anyway. But this is, I've indicated this is optional. It's like in red there. So if you know it, you don't need to attend it. If you do not, yeah, you know what I mean. If you don't, tough. All right, so this first part of the lecture is kind of Hello World Cloud. It's kind of the high-level versions of, why do we have clouds? What are they for? What is a cloud? And things of this nature. So I guess historically we've really been in the cloud era for the last 10 years maximum, I'd say, maybe slightly less than that. And most of it's been driven by marketing, and certainly the technology is picking up now. But in the early days, it was a lot less robust and a lot more vision of the future as opposed to the practical realities of the tech at the time. There are many different flavors of cloud. So you have infrastructure as a service, which is the kind of cloud you're going to get access to. You're going to log into the cloud that we offer you, and you're going to have a virtual machine, which is kind of empty. You now install, I want that particular operating system, and I want this app, and I want this database, and I want this. And you are manually building these things up. That's infrastructure as a service. There's the other alternative, which is already pre-deployed, all built and configured, and you just start it up. Sort of like software as a service. So there's many different flavors of doing these things. And we're going to take you through a hands-on workshop. When Farzad gets here a bit later, he'll take you through you should all be able to log into the dashboard. You should all be able to follow his recipe for creating cloud instances and doing various things. But as I mentioned in the early lecture, just because you can log into a dashboard and you can SSH onto a machine, and you can do a sudo app install, whatever it might be, or you can install stuff, that from my side is not cloud. It's only when you learn how to script things, when you can say, install this on 1,000 machines, which you have access to. That's when you start, and then you say, when the load goes above a certain threshold, I need more resources. I don't want to keep on paying them forever. As soon as the throughput is lessened, I fold it back down. Teaching you how to do that is kind of, when you start doing that, is kind of where you're really, from my side, doing real cloud. And Yao Pan, who does this for a living, I guess you can say now, is going to take you through some of the script. There's many ways to do that. There are tools, there are scripting languages. We're going to take you through one of the main ones that you need for your assignment, which is called Ansible. It's one of the easiest scripting languages available, but there are literally tons of these kind of things. Configuring servers, installing, patching, etc., etc. You don't do it as a sysadmin. You don't do it. Typically, you're not working with one machine at a time. You're writing a script that can run and configure a bunch of machines and that kind of stuff. So I guess when you start moving into that, you're moving from software development more into sort of sysadmin. And that's kind of, you need to have that little bit of background in how the technology and how the servers work to be able to configure them and run them. And then as I say, we get into a bit of Gitting. So before we had clouds, we had people would buy large scale. If you all went to the data center, or many of you did, I guess now you sort of see how we have all of those centralized resources, cost millions and millions of dollars. And sometimes they are being hammered. Sometimes they go down and no one's using them anymore. And so you have these moments where you're paying for kit and sysadmins and no one's using it. And that's not an uncommon thing. If you were running a company, you might have time just before Christmas when everyone's logging in to buy their thing, and then after Christmas, the load on the servers go down. You don't need all those servers, but if you bought all that kit, you're now exposed to, well, we bought all this stuff, what do we do now? This is the sweet spot where cloud fits in. You have the two choices. You can either buy all the kit you need and over-provision just for those spikes, or under-provision, and just, you'll have a threshold, which is when it's hit, it's hit. So that's kind of where the cloud model, a lot of the original cloud ideas have come from. Trying to find ways to allow people to use external resources that can either be managed and give you infinite scalability. You can have 1,000 or 1,000,000 or 1,000,000,000,000 people logging in and doing stuff, and in principle, you just scale out. Or you can scale back down. So you pay for it when you need it. And that's kind of the basic model of cloud. I mean, that's kind of, it's somewhere else. You're paying for it on demand. Or for you're not paying for it. Well, you had this description before. You are paying it through paying the Univalve, but in principle, it's free. I access the cloud in Australia. It's all free to me, kind of thing. But if you're using Amazon or some others, you clock up bills pretty quick. And we'll go into a bit of pricing and options in that place too. But the basic idea is they give you this opportunity to use the resources you actually need as and when you need them. And that's kind of the basic idea. So you have the spikes. You have times when it's, if you have a steady stream of jobs and a steady stream of data processing, you can very accurately identify how much you need at any given time. Reality is we deal with lots of stuff where you have spikes. If I think now, go back 5 years to teaching this class, there'd be 50 students. Now there's nearly 400. So obviously the capacity is growing, and if I was teaching this class using the same resources I did 5 years ago, I'd now have to buy 8 times as much kit to support it. So we have these moments when you need a lot and then you need a little, and that's kind of the basic idea behind cloud. So the question is, should you buy your own, or should you just pay Amazon or Azure or Google or whoever it is who's giving you the cloud? What should you do? So this was a bunch of slides when cloud was first happening from my side in 2009, and I was asked to go and give a presentation at the time about what we're doing with cloud at some big conference. At the time, we had our own ScotGrid infrastructure, which was a high-performance computing, a bit like Spartan, a bit like one of those sort of what you saw in the data center. And it was reasonably large at the time. We had 1,000 cores. We had 95, whatever it is, 85 terabytes of storage, et cetera, et cetera. And this thing ran as our main facility on campus for about 3 years. And it was, like Spartan, hammered. Everyone was using it all the time. And that was it. And it was used by many groups for doing all kinds of different things. So it was the Higgs boson folks in physics land. It was a bunch of biomedical engineers. It was the Nano CMOS project, the electronic engineers looking for next generation computer chip design, etc. Lots of people would log in and do random stuff, running PBS, not SLAM in those days. It's a slightly different. Instead of doing SBatch, they're doing QSub, different kind of syntax for submitting jobs, but the principle was the same. You'd log into a head node, you'd write your little script, and then this thing would decide which servers would run your job. And everyone would have their favorite sort of software and systems installed and configured, and people were quite happy doing that. We had lots of different people doing lots of different things, thousands and thousands of jobs. I think Spartan's like 8 million or something now. You can see how much time these jobs take to run, not just the number of jobs. Some jobs, your job might take a minute. Some other jobs might take a week. So you can track how much resource is being used, etc. And then I was asked, how much would it have cost if we would have done this on Amazon at the time? Amazon pricing model once upon a time was pretty simple. Now you need a PhD in economics to work out how much it's going to cost you a lot of the time. You can have spot prices, reserve prices, you can have last minute offer kind of prices. You can say, I need to reserve it for the next 5 years, you get some special rates. There's a lot of it, modeling goes into this. And historically it used to be, they'd always round it up. You wanted an hour, you used an hour and 1 minute, now you pay for 2 hours. Now they're doing it per second. But they're not doing it because they're nice, they're doing it because people said, this is not right. You shouldn't be doing it, and customers started walking away, so Mr. Bezos and Mr. Amazon decided, okay, we'll fix this, we'll do it this way. But now they track you per second, effectively. So we had lots of different resources available, which you had at the time. If you log into Amazon and you want to launch a virtual machine, similarly with Nectar or Unimelb Cloud, you'll see there's lots of different types. You can have the little one, the medium one, the large one, the extra, extra large, etc., etc. You won't get access to the extra, extra large. We do, but you don't need them, I guess, at the end of the day. But they all have different prices. To have a little mini VM for a little while, it costs you, I probably should know the answers to this, but it costs a little bit of money, although that money is increasingly expensive. But if you want the larger machines, which are going to do more serious crunching of data, they cost a lot more. And at the time, it was $1 was 69 pence, UK pounds. And if you actually just looked at the number of jobs we processed on ScotGrid and worked out how much would this have cost for the CPU time, how many CPU hours did we use running on our own cluster? If we were to take them jobs and run them on Amazon, then it was going to cost us over £2 million. So it was way, way, way more expensive than, and that was just for the jobs. Where Amazon gets a lot of money, and I pick on Amazon because they're the biggest and they're easy to pick on. But they get a lot more money, not from CPU hours, how many CPUs are you chewing through? Storage, input and output. So generally they make it very easy and cheap or free to put your data there. You want to get your data out, show us your money. So they're very clever at doing a lot of this stuff. So So, long story short, it's a lot more expensive. It was, and it still is. So we have some projects in the last couple of years where we've done some really big data crunching, processing data from drones flying over buildings and looking at where trees are growing and all this kind of stuff. And that would have been about $400,000 a year just for the processing of that data. And that's not us owning stuff. This is just how much it was going to cost us to process these jobs on Amazon at the time. So it gets very, very expensive very quickly. So, yeah, so pricing, and again, Amazon pricing is, if you start looking at how much does this stuff cost, it gets very, very complicated very quickly. So really the focus of this lecture is not to bitch about Amazon and that kind of stuff. It's easy to do that. It's really to give you a flavor of what do I mean when I say cloud, because it's like confusion. I mean, it's very confusing. What is cloud? Is Gmail cloud? Is Dropbox cloud? Is obviously Amazon? But there are many different levels of what do we mean by cloud, and people are spinning all their own out there. Later on, we're going to get into how does the tech actually work? How do you get a physical server being used by multiple virtual machines where they're all physically sharing that same server and the same storage and the same kind of hardware? How does that happen? And there are many ways of doing that now. So there's not just one. In the old days, there is a hypervisor, but you have many different flavors of hypervisor now. Some are faster, some are using certain APIs to do certain system calls. So there's a range. There isn't just one recipe for doing it. There's a range of recipes, which we'll talk about in one of the later lectures. So, again, when the marketing people get access to the opportunity to tell a story, they are very good at making all this visions of the future. So, as a service is now a buzzword. You can have big data as a service, teaching as a service, platform as a service, infrastructure as a service, networking as a service. All of these things are completely true. You can write software that will configure the network. You can have data as a service. You make services available which give access to distributed data. People don't need to. Orin is probably a data as a service platform. You log in, you say, I want this data. We're getting data from Vic Police or the ABS or wherever it is. You don't know where that's coming from. Well, you do because you're asking for it. But in principle, the technology is providing levels of transparency where you don't know if I'm getting that from America or wherever it might be. So there is a lot of confusion in that space. So when marketing people have a look at, how do we define what is a cloud, they'll spin it a different way. There are probably a few common mainstream ways of describing the different types of cloud, which these aren't the only ones, but these are the ones that are most prevalent based on the technologies that have been largely adopted. So you have private clouds, as in when you use the cloud that we give you access to, that's only for people from the University of Melbourne. So that's the UniMelb cloud. People from Monash or wherever, click on Monash again, can't log in. So we restrict that to University of Melbourne research. So this is our own private cloud. You have your public clouds. You have the Nectar cloud, as example. And these two are the same kind of technology. Under the hood, it's OpenStack. So it's the same kind of tech, software that is being used to make these servers only UniMelb and these servers for everybody else. So you have a variety of these sort of private, public. You can have hybrid versions of that. So what happens if we're processing some data on our cloud and then we run out of CPUs or storage and we need to submit that paper to that conference next week and we need the data and all the virtual machines are taken by those master's students and I need to get my research out, you can burst into public cloud. So there's a range of sort of versions of the cloud infrastructure, I guess you can say. On top of that, you can then have a range of different ways of describing how they are realized. So software as a service. You've got your software, you've got your application, it's all running with processing your data, and now you need to run that somewhere else. You've built all of this virtual machine, this instance, with doing what you want, and you want to make it run somewhere else. Or it's already built by somebody else somewhere else, and you're just using the thing. So software as a service is probably most non-computer scientists are very familiar with software as a service. They're just using something that's built by someone else. Platform as a service is something in the middle. The platform, the infrastructure itself, has got a range of capabilities which lend itself to make it easier for application developers to roll out apps across that infrastructure. We'll talk about some of these in a tick. Right through to what you're going to experience, which is really where cloud starts, which is infrastructure as a service. Congratulations, you've logged into the cloud. You have a bunch of servers. Now make it do stuff. And you as software engineers have to write your Python, write your Java, write your whatever it is you're writing, install, configure, and then work out how do I make this thing run here, 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 here. That kind of, but the cloud itself is not really helping you. It's not giving you features, it's not giving you capabilities, it's not doing special stuff. You as software engineers have to program it. You're going to write a bit of Ansible, you're going to learn how to launch stuff, you're going to write little scripting files, install this, and then make that run on these servers, and make all those servers talk to this thing over here. Yao-Pan will go through some of those practical examples of doing that in a while. But ultimately, I guess a lot of the time when we're talking cloud, we have a range of capabilities we always want. It's got to be on demand. It's got to be easy for customers. You obviously need the big pipes connecting it to the broader world. We obviously have data centers for a reason, because pooling those resources into that data center allows them to be easier managed. When you're really doing cloud, you have scalability. And elasticity is another way of describing it. So not just the case of, hey, I've got 4 servers that are all collecting Twitter data and feeding it into my database. Congratulations. You've built something which is useful. If you then said, okay, now make it scale to 100 servers, or 50 servers, or repurpose them to only collect data about Donald Trump, how do you do that where you're not manually tweaking stuff on every single server? You want those kind of capabilities. And especially when you're dealing with commercial cloud, you want to measure this stuff, because they will charge you if they can. And you measuring the load, and that can be from many different ways. The input-output, the CPU, the storage, there's a range of things you want to measure when you're using clouds effectively. They all have their own advantages and disadvantages. So public clouds, it's kind of utility computing. You don't have to care about anything. You know, Mr. Amazon's managing all them servers for you, or Mr. Rackspace, or whoever it is. You're just using it. So they create the instances. You swipe your credit card, you get access, you do stuff. And Mr. Amazon's managing all of that, making sure it's, if you've swiped the card in the right way, I want backup of all my systems, and I want to have, load balancing, and I want to have, they give you a big shopping list. You say, I want that, I want that, I want that, and then your credit card is, getting hit. Every time the more you tick, the more it pays. They charge you. But it's very effective for many organizations. It's kind of what they want. They are quite happy to support, have all of this, somebody else managing all of this. If you're a company that produces stuff and you're not IT, why would you? Why would you have a bunch of software engineers and HPC admins and all those kind of networking people when if you're selling pottery? You wouldn't. I mean, it's not your business. Your business is creating pottery and selling pottery. You need somebody else to do this. Build me a website. And by the way, I need databases, and you need it integrated with all these other services that are for charging and security and all that kind of stuff. Mr. Amazon comes along and says, I can do all of that. Just swipe your credit card and I will do it for you. I guess the benefit of public clouds is that they give you this, what they call right sizing. You can get as much as you want. So if I need 10 or 100 or 2, if I need 1,000, in principle, it's there. I can just, again, pay them money, and it will give me exactly what I want when I want it. The downside of public clouds is obviously a big one. One of the biggest things and one of the major issues with clouds right now, which still has not gone away, is security. Who the hell is looking at my data or my applications or my business when it's in cloud land? So we'll talk about that later on, but there is, and I mentioned that at the data center, there's nothing to stop someone logging into those virtual machines and having a look and doing stuff. Amazon can't stop that. They say that, Amazon again. Whoever is responsible for that data center and whoever is that sysadmin can do what the hell they want, because they are masters of the universe in those areas. So, and this is a major, major issue, because now when we run to businesses or government or medical, who's accessing those services, who can see, the fact that someone had an operation or someone had an abortion, all that kind of stuff is like a minefield of who's allowed access to this data. And so there's a major, major issue. And once you're out there, you've lost control. And that's kind of the main issue. You can't say, okay, I delete my data, or I want it back. Because once it's on the internet, or once it's gone somewhere, if someone leaks it somewhere else, you can't really, it's kind of the Zuckerberg movie. Once it's out there, it's in ink. You can't just erase it. Someone's backed it up somewhere. Even Mr. Zuckerberg, when he says, I've lost all my early Facebook posts, or whatever he said way back when, and says, no, we've already backed them up over here in the Zuckerberg file, so you can't get rid of it. And he's Mr. Facebook, and he can't get rid of his data because someone somewhere's copied it. Lots of things like this are real issues with public clouds. They tend to lock you in. So if you're using Amazon, they're just slightly different enough that they won't work perfectly with other cloud infrastructures unless you're prepared to be more of a software engineer or a DevOps. So you can make it run on multiple, but it doesn't come free. And ultimately, you're depending on these things persisting. There's lots of examples where providers have, we'll offer you services, or MySpace, or whatever it might be, things way back when where you put your data there and you think it's all great, and suddenly that business goes away and you've lost all of your data. These are all real issues. Okay, you could say the same thing with if Unimel private cloud, if Unimel went bankrupt, then, okay, we've lost all the data anyway. There's no more Unimelbon. But at least we are masters of our own destiny. We are not dependent on some external agency that isn't our business persisting. And you can't always guarantee that a lot of the time. Private clouds, you get much more control. You can consolidate your own resources. It's easier to put a big ring fence around your university firewall or your organizational firewall and saying this belongs to us, and we stop all incoming connections, etc. You obviously have much more trust in the things you're coping with locally, so that's a good thing. You want to be able to manage these things like medical records that are being collected at the University of Melbourne for research are managed in a way which we know who's accessing them and how, and because we are in charge of all of that. But the issue is not all people can do those kind of things. So you may not be able to do your own private cloud. You might not have the technical people available. You might not even know how to build a website. Never mind, get into grips with cloud technology. So another downside of this is that you have to pay people now. So we have dozens of people who are managing all of this stuff, and each one of them are getting paid. Your university fees are paying someone to help with a lot of this stuff. For a big organization like the University of Melbourne, which is like $1 billion a year kind of business, we can do that. But if you're a small or a medium business with maybe 10 techies or 5, you're just growing your pottery business, you might not be able to do that until you become established, and then you have the resources to control it. So staff overheads is a big thing. If you buy, I took you to the data center. Let's just say Mr. Dell or Mr. whoever comes out with the latest, greatest computer, which puts all the others to shame. Now we just spent $1 million on kit. Now what do? Do we throw it away, or we just carry on with this while we're waiting for the next thing to come? With Mr. Amazon or Mr. whoever it is, they're always giving you, we have the latest, greatest toys, you can use them all. And then, again, what happens? We spend all this money on our private cloud, and then we don't have enough people to use it. We bought all that kit, we've invested all our money, but we don't have the user base that we thought we'd have. It's very difficult to gauge how much kit and how much resources you need. It's actually, you'd think it'd be fairly straightforward, but it's much more complicated. How many will take this class next year? I have no idea. No one knows. More. All I know is it's going to be more, because it's always more. But how much more, I'm not sure. But if someone would have told me 5 years ago there'd be nearly 400, I would have thought, no way, this is ridiculous. But more and more and more. Hybrid clouds is the other alternative. So this is where you have this combination of both, where you can use your private cloud, but as and when you need, when the load increases and you need to use more resources than you have, you can burst onto the cloud. So there are ways of doing that too. It's more challenging than just the tech though. What data can move there? Who decides what data can move from your private to your public, and when? And is this like some program doing this, or is there some university policy? We're processing genetics data. Obviously, we can't put that onto the public cloud if it's cancer data from patients at Peter Mac. But understanding what researchers are doing what with what data and what can go public is, again, a complicated thing. And do we know where we should publish to? So if we want to go to Amazon, or we want to go to Azure, or we want to go somewhere else, which one? Why? Are some better than others, maybe in terms of the security? Maybe they've got better networking. Maybe they have better backup systems. There are trade-offs in all of these things. The cloud providers themselves are going to say, we do it all, give us your business. But they've been saying that for a long, long time. And yet we still have our data center, and we're still using it for most of our projects. We have a few, which we're using Amazon now and Azure now, but for the most part, nearly all my projects and all the things we're doing are on Unimelb resources. So the infrastructure as a service, platform as a service, and software as a service, they have various levels of how much is required from a techie to build and support these platforms. Your on-premise scenario is, it's all done. It's all done there. It's all provided for you. And you manage the whole lot. You're managing Unimelb data center, let's say. So we manage the network, the storage, the servers. We install the various OpenStack software or VMware or wherever it might be. We decide which version of Ubuntu or Fedora or Windows or whatever it might be. We decide which middleware, et cetera, right up. So we do everything. In other, say in Nectarland or in the UniCloud side, you don't get choice here. They give you all of that. What you have access to, once you've logged in, you can say, oh, I'd like that flavor of operating system, and I want to launch this particular type of software on there, etc. But there's only so far down the stack you can go. Your platform as a service is even less, gives you even less access to do stuff. You're basically pretty much restricted to get your data in there, install your apps, and go. You don't get much choice of all the things that lie below there. And your software as a service is generally, it's all done. You just use the thing. So there are many examples of all of these, I guess. So your public software as a service is, Gmail. Many people use Gmail now as the main. Your Unimelb email gets straight away to Gmail, and it's illegal, by the way. You're not supposed to do it. Most academics are doing it, and they're not supposed to do it as well. But people do it because they like Gmail. They don't like Exchange and Outlook, etc. But there are many, many examples of these pre-built, perfectly working, highly reliable, very robust services that are out there that you just use as part of your daily using the internet, I guess you could say now. There are many public platform as a service examples that are out there now. So you have your Google App Engines, you have your Microsoft Azure, comes with all the favorite flavors of this is the way to do it, Microsoft style, etc., etc. There's people in the university here, Professor Boyer, who built his own middleware platform called Annika, which runs a bunch of scientific stuff. There are many examples of these. It comes with all the kind of tooling you need to be able to plug in your data, plug in your applications, and it will support you there. Your infrastructure as a service is probably the most, from my side, where it all starts. All of those things are just adding on features which allow you access to. You can rebuild. In fact, most of those previous ones are built on this stuff. And in your assignment, you're doing this, and you're building software, which is going to be running across the cloud. But there are many, many examples of these infrastructure as a service providers who give you access to literally good networking, potential infinite storage, and as many servers as you can pay for. And there are lots of them. They all have their own advantages, disadvantages, etc., etc. One of the big advantages is pricing, or the pricing model is interesting. So they don't all charge the same stuff. They all charge different rates and different hourly rates and different sort of storage rates, etc. But luckily, you're using this one, which is the free stuff. But actually, that's not true. You've all paid anywhere between N,000 and 10 N,000 to sit in here and hear me rattle on about stuff. So you've all paid. But it just so happens that this, for academic researchers in Australia, or students in Australia in principle, is free. It's never free. My tax pays for this. So when I get smashed by the tax man all the time. And this money goes to the federal government. They decide how much they're going to put into the universities, which is going down, down, down. So someone's always paying for it. It just means that the resource you're going to use is largely underwritten by somebody else. So just a bit of background on these clouds. I mean, I've flagged now we're going to do a bit of a demo. There is 2 clouds, or several clouds that we have available now. Historically, we've had this thing called NECTA, which is the National E-Research Collaboration Tools and Resources, which was my acronym. I came up with that one about 8 years ago. I liked ARS and E. coli, but they wouldn't allow me to call it either of those. So I had good reasons to say the Australian research something or other, but they thought my humor was inappropriate. So you've seen the data center. You've seen all the storage and compute that's available there. For most people, that's, look at all the flashy lights and look at all the cables. It must be very hard to do anything there. It makes no sense whatsoever if you're a biologist or you're a chemist or you're in humanities. These people do not live in that world. And yet we have, NECTA was to build the large-scale national cloud, which we're going to talk about in a there are many availability zones. We have ones in Queensbury Hall, where many of you have been now. You've seen those racks of computers. Some of them are hosting NECTA kit, running stuff for researchers in astronomy to particle physics to whoever, all in that facility. But we have the same. You can run your jobs in Canberra or Brisbane or Perth or Monash. There's about 30,000 servers available, and that number's going up and up and up. So they're just putting yet more money into this. They just got $72 million for yet more of this stuff. So the government's putting a lot of money into this just for academic stuff. Whether that's going to equate to, Australia wins Nobel Prizes and this kind of stuff. I guess at the end of the day, if it results in more students coming to the universities from international, that's probably worth more money than having Nobel Prizes. But I guess a large part of the story is trying to build software for researchers to use this stuff. So NECTA funded a whole bunch of what they call virtual laboratories. You don't really have to worry about it, but it was not just a case of, we're going to build a cloud. It was not just like building it and hope they come. It was a case of, we're going to build it, and then we're going to give people $1 million, and I had one of these, to say, build a bunch of things that people would want to use this resource for, and make it like super amazing science and this kind of stuff. So there were many of them across all disciplines, from the arts and humanities to sciences to you name it. So NECTA was one great big project. National Cloud, still running, just got a bunch more money. They've connected NECTA, because originally we had a project called NECTA. There was a project called for storage, which was kind of stupid. We have let's give them $100 million for computers and give them $100 million for storage, and they don't talk to each other. So it was kind of stupid beyond belief, but it wasn't my call. So we have a national storage system now. So you're going to be using parts of the storage. When you get into your assignment, you access and use that. I mean, in principle, we have hundreds of petabytes of storage across Australia now for all kinds of stuff, and that number is just going to go up and up and up. So as long as we don't make the government look stupid with that $72 million, we get more money, and it looks like it will happen forever. Gluing all them things together. So we've got compute, we've got storage, we've got security through the Access Federation, et cetera, You want to be able to connect all them things. So we're going to, in one of the later lectures, we're going to go into much more detail on this. But there is some software that is used, which is the open source cloud middleware, I guess you can call it, which is called OpenStack. If you want to get a quick look into some of this, then you go to the URL there. But OpenStack is probably 1,000 different companies around the world who are all trying to build this common way of doing cloud. So if you're building a virtual machine here or a way of connecting your storage here, it should be able to access and use the same kind of services somewhere else. There are many, many capabilities in OpenStack. Creating servers, attaching storage, attaching volumes, measuring the performance of your virtual machine, doing security, et cetera. Even like the front-end dashboard is all part of OpenStack. And so we'll talk more in detail how this all works and how it actually realizes the cloud and how it relates to the managing servers, et cetera. But this is a very much a global sort of effort, effectively. Whether it's going to be successful, time will tell. Well, it's kind of successful now. Everyone's using it. There's lots of people, tens of thousands of people around the world are using these kind of OpenStack-based services, and etc. But still, Mr. Amazon and a few others are controlling the market, and they're involved in these things, but it's really not in their interest to make this a success, because if it was, people could just move from Amazon to Rackspace or Azure straight away. And that's the business proposition is always there. If you logged into Nectar or the UniCloud, you're going to see there's a bunch of, right now, if you all logged in, you don't have to do it now, we'll get into this in a tick. You'd access a small virtual machine with 4 gigs of memory, and it's got 30 gigs of storage on there, and that's a freebie. I don't have to do anything there. I don't have to set you up. It's kind of anyone who's got a .edu.au email can log in from RMIT or Wollongong or wherever you are and say, I want to log in and I want to get a server. You get a server for free, a small one. To get more, you have to ask. And generally speaking, if you ask, unless I supervise your project, they're going to say bugger off. But if I supervise your dissertation, for example, and you need 4 virtual machines and a terabyte of storage, you write a little application on the dashboard of Nectar. It gets assessed, and they say OK, generally. But in principle, you could say I want 1,000 virtual machines and a petabyte of storage. They're definitely not going to give you this. But in principle, we have a lot of resources that are available. In your assignment, you're going to get 4 medium VMs of memory serves, and you're going to get about 1/4 of a terabyte of storage. And I can easily extend that. If you implemented the most amazing harvesters and you've got terabytes of data, we can give you more. The CPUs, I probably can't give you more. You're always limited there. But storage is easy. So we have tons of storage available, but the actual compute is too many people have them. And people like me tend to, once I get them, and Yaupan and Farzad, once we get them, we don't give them back. So it's not really the cloud model. The cloud, if this was Amazon, I would say you can have it back now. I don't want to pay. But generally speaking, when you get the resources from Nectar, you kind of allowed to keep them forever and ever. So we have a few thousand virtual machines just doing random stuff now. But for you, you'll have it for 6 weeks or so. When I set the assignments, one of the things I'm going to have to do is add everyone into those teams on Nectar. And then once I've done that, you'll have 6 weeks to build an amazing system. You're going to demonstrate it to everyone. At the end of that, Mr. Nectar is just going to say, nuke the lot. So all your hard work will be removed and destroyed forever, unless you back it up somewhere, which you can, obviously. But that's generally how the model works. In fact, when you create a video of your system, which some people do, rather than go live with a demo at the front, they have a YouTube version of their system, which is always a safe, and it's kind of a cop-out for the live demonstration. That will last much longer than your Nectar resource. OK, so that was kind of the end of this intro. I guess it was pretty high level. But what we're going to do now in the next, I'll take a break for 10 minutes, and Farzad will come over. And we'll just take you through logging in and doing some hello world. This is how to launch a virtual machine, an instance, etc., and do some basic configuring a firewall. OK? Yeah, is it? Yeah, you're good. OK, folks, so as I mentioned earlier on, everyone, for me to be able to give you access to the whole of the cloud to do some of the actual experiments and repeat the scenarios that Farzad's going to do, you have to log in at least once to the cloud. I can't do it beforehand. So if you logged in now, you're not going to be able to do all of these things because you don't have the availability of volumes to attach, etc. I can only do that once you've logged in once. That makes sense. So if you want to just follow the first part of this, you can certainly log in. You can create an instance. You have a small mini virtual machine for free, I'm assuming.
Yep.
And then you can do the first part. But let me know when. Oh, I guess I'm not. I will just literally try every single combo of adding people and saying I can add you to team 1, etc. But I can only do this with using the same email address that you use to log into dashboard with. Okay. All right.
Hello, everyone. Hope everything is fine with the first assignment. I know a lot of you are busy doing that. So just keep asking us any questions that you have on LMS. We are happy to help. So this is one of the key parts in your second assignments because everything that you do needs to do with the Nectar Cloud, or let's call it Unimel Cloud from now on. So please pay attention to see how we can, so today what we are going to see is that how we can launch a virtual machine on the cloud, how we can access it remotely, how we can like install a typical software on it, how we can like attach external volume or storage to our virtual machines. So this is going to be basically what we are going to do today. So I think it's easier if I skip the slide so you can just always study it yourself. I would just directly jump into the demonstration. Okay, so the first thing that you need to do is that you need to log into the Unimel Cloud. So the address is dashboard.cloud.unimel.edu.au. And when you type in the address, you will be redirected to the login page. From here, you'll log in with your university credentials. Okay, so okay, so this is the OpenStack dashboard, or what they call it, Horizon. So here you will find the projects that are being assigned to you. So now I have like 2 projects here. So the first one is the default one that if you try logging in now, you can see that the first project is there. So you can create 2 virtual instances there. I have another project which I'm going to use now for like demonstration. It's one of like the group projects that you can actually, it will be assigned to you later on.
Just to flag us again on that, I will have about 10 different sort of people like Farzad and Yaupan. I'm going to add them to your team. So if you have a problem with your instance or as the assignments go, so you'll find when you have if you're team 1, you'll see, right now you'll see, if you logged in, team 1's in here, you'll see Yaupan and Farzad are already there.
Yep.
Ignore that. Yeah. So Yaupan will be taken away to begin once Farzad's done the demo, but there'll be an extra person in each team who are helping with the course effectively. These are the kind of people that you ask questions of. Because if I have 400 people asking me about my SSH key is whatever, I'll melt. So don't be surprised when there's an extra name in your team.
So we would be spying basically what you are doing.
And also we know when teams have started. So just to let you know, we can see if teams after 3 weeks have still not spun up an instance or done any work, we can approach you and say, we noticed you're not doing stuff, do stuff.
Okay, so what I'm going to first do is that I'm going to change my project from the default one to the second project. And in that home screen, you can see that you have got an overview of what resources has been allocated to you. So this is exactly, I think, one of the groups that you will be assigned to you. So you can see you can create up to 4 instances here. And this is the number of virtual CPUs that you can have. The maximum number of RAM that is allocated to you, number of storage, floating IPs, everything that you need is like summarized in this page. So for creating a new instance, we go to the Instances tab under the Compute section. It's going to take a while. Yes.
On my dashboard, it's not showing the project.
Yeah,
Yes,
so,
it doesn't show. Yep.
So as I say, if everyone logged in now, you'd see PT 1, 2, 3, 4.
Yeah.
Let's say you're not going to see Group 1 because everyone has to log in. So they all look the same. They all say Unimel conf 90024 Group 1, Group 2, Group 3, Group 80. But you'll only see that when I've added all that Google sheet where there's Team 1 is 5 people and Team 2 is whatever. I have to add you manually. Once everyone's logged in at least once, I have to manually add 5 people to Team 1. And I'll do the same. And then once I've done that, next time you log in, you'll see you've got PT 1, 2, 3, 4 and Group 1 or Group 27, as the case may be.
Yep, it is still loading. I will try to reload it. You can follow what I'm doing. Just use the default project that is like assigned to you. That should be fine.
Mine is also spinning, it's not going.
Oh, okay. So let's see which project are we. Okay, yes, we are in this project, but there is a Wi-Fi issue. Maybe. I think so. It was working just fine. Yeah, I think it's a network issue, so I will try connecting to the Wi-Fi. Okay, looks like the Wi-Fi is down. I will connect to it. Nectar is down.
All of Nectar?
Looks like the Wi-Fi is down. Yeah. Let's see.
Not just the Unimel one. All of
Yeah, the
Nectar.
Wi-Fi is okay. Might be back. Yeah, looks like it is doing something. Let's see. We broke the Nectar.
But it's okay for you now? It's completely dead.
Okay. Yep, looks like. Yep. I want to see if we can access it here.
So it looks like the Unimel clouds just fell over. You killed the cloud. It's pretty much the same. So there's some
Same
slight
features.
differences.
Yeah, same features, different kind of UI.
Seems to be going really slow no matter what.
Yep. Okay. Yep. So this one is working, but I don't know why this one is not. Okay, looks like there is a problem with the Unimel version of the cloud. So we will keep using the Nectar. So the dashboard and the features are pretty much the same. Just a little bit of like UI might be a little bit different. But everything is working for you?
So
If
is
you can
anybody
for all
logged
of-
into the Unimel cloud okay?
Yeah.
So your login is fine. Can you see the instances? If you go to
It
the...
doesn't really matter. I guess at the end of the day, we're going to do the demo on Nectar. It'll look more or less the same as the Unimel cloud.
No, click the instances one. That page looks like the difference.
So but having access to the dashboard, it's actually creating an instance. That's really where there seems to be an issue right now. But we use the Nectar cloud, but it's the same. I mean, it's the actual same OpenStack thing. The only difference is it's being partitioned for Unimel.
Yep. Okay. So we are now in the instances tab. So what we are going to do is that we are going to create a new virtual machine. So we click this launch instance button here. Okay, so first we need to give it a name. So let's give it like, and then you can fill it any description. So here, this is what is difference with the Unimel version. So here you can see we have different availability zones that we can select from. So when you log in from the Unimel cloud, so there is only one availability zone selected by default. Okay, so if you can access, you can just click that one. So what I'm going to do is that I'm going to select it manually. So this is the number of virtual machines that you want. So if you want to create more than one, all have a similar feature, you can increase this count. Then you click the source tab. This is where you select the boot options. So the image that you want to select for booting your virtual machine. So you have to give it some time. It's gonna take some time to load this page. I don't know why. But then after that, you can click this image here and then select your image. Yep. So from here you say, okay, I want to select Ubuntu. Okay, so this is a list of images that you can select from. So I'm going to go with this one. Then you click this arrows, so it is being added to this list. Then you go to the next tab. Yes?
The images contain configuration up to which point? Only Windows
OS.
operating system?
Basically operating system. There are some like images that have some other like packages built into them, but what you can find here is mostly like the operating system. So it is either Ubuntu, Fedora, CentOS, different types of operating systems that you want to choose from. Do you have any questions?
Yeah, so mine didn't let me select a source, but it said none were available, but it lets me select a flavor.
Are you on Nectar or are you on Unimel? Right now,
Unimel?
for Unimel, Cloud is having a few.
Okay.
No, but this should be the same. Just only the availability zone should be
If you want to log
different.
into Nectar, you can log into Nectar.
Yeah.
So you go to Dashboard RC, Unimel, Venue, AU, Nectar, whatever it is,
Okay, so it should.
and
it
then you
should
can follow
show
the
me-
rest of it there. You get the same experience.
Yeah, okay. But it should show me a source.
Yep. Trying to load this one again at the same time. Hopefully it's gonna work. If it works. Okay, so what you do here is that you're gonna choose the flavor. Flavor says, okay, what is the configuration of the virtual machine that you want to launch? How many virtual CPUs? How much RAM? How much storage you want? So you can read it from here. So you can see this tiny one has like one virtual CPU, this amount of RAM, and this amount of default storage. And like there are many different types of flavors that you can choose from. So I'm gonna go with this like small one, with this M1 that is small. So when you select it, then you go to the networks tab. Here you don't need to change anything basically. There can be like multiple available networks, but this one gives you a public IP that you can SSH into your instance. So just leave it as it is. Just choose the classic provider. The next section is the security groups. So security groups defines what ports are open on your instance by default, and later on if you want to say, okay, for example, I have developed a web service and I need Apache to be listening to port 80, you can tell your virtual machine to start listening for connections coming for port 80. So this is basically like configuring the firewall for your virtual machine.
Just on that point as well, be very wary of that one. Don't just open all ports, obviously, because you're just going to get smashed by something or someone. So, right, default is it opens SSH. And so you can SSH onto that server once it's created. You should be conservative in which ports you open and why you open them. So just to flag that here. So, because if you open up all ports, people will just hack in and do some bad stuff to you.
Can I limit by IP?
Yes?
Yeah.
Yep. So I will show you later on how you can limit those things by IP as well. So here I'm going to add like, so this is going to be a list of, so you select the security group and then it's going to be some rules that you define within that security group. So there are like 3 that has been there added for you by default. And I'm going to select and add this SSH as well so you can log in to your instance. And the next step is like choosing the keeper. So keeper is your access credentials that you use for logging into your instance. So by default, I think most of you won't have any keeper added to your account. So you need to either create a new one or import a keeper. So there are instructions of how you can do that. So if you click this import keeper, oh, I think it's not here. It was in that dashboard that we could see. Okay, this one, definitely we have some server problems. So I will show you later how you can import a keeper or create a new keeper. So let's say you have done it. So then you select it from this list. So you see my keeper has been added here. And then when it is done, you just leave the rest as it is and then click launch instance. So this is going to take a while. And while it is doing that, hopefully, I can show you how to do the keeper thing. No, I think it is running in background. It takes a while. Oh, that's the old one, yeah. This is the one that I created. So you can see now the new one is in the queue to be spawned. So it's going to take, I think, up to a minute sometimes.
So what happens at the back end of this now is the OpenStack software. There's a service called Nova, which is your computer trying to spawn up an instance. It's talking to another component which is saying what type of instance. It's Ubuntu. It's saying how you want storage attached to it. So there's a whole range of OpenStack components right now which are all interacting to deploy and build that server, as well as all the IP rules and only SSH access, etc. So that's kind of what OpenStack is doing. It's not just a passive thing.
Okay, so while this one is building, so we can go to the keepers tab. So here you can, as I said, import your public key or create a new keeper if you don't have any. So if you click this one, you can see the instruction is here. So if you are on Mac or Linux operating system, you can just follow the instruction here to generate a keeper. And then you just need to give it a name here and import your public key. Definitely you're not going to disclose your private key to anyone. So keep it safe, but you can just copy and paste your public key here, and then when you click import, it's going to be added there as a keeper. So this is what I have done for my key here, okay? Or if you want to create a new one, you just click that create keeper, you give it a name, then it's going to download. Let's do it, for example. I'm going to, so when you hit this one, oh, it should have downloaded a file. Oh yeah, here it is. So you can see it downloaded a file called test.pem. So what you need to do with this file is that you're gonna, this is your private key. Okay, so the public key has been already added it here. That's why you see the key's name is here. So you just need to change the permission of this private key that you just downloaded. So it should be only readable by the owner. So it is a command like this. So if you say chmod 600 and then give it the name. Something like that. So this is the first step that you need to do, and then you can use this key file for connecting to your instance, which I'm going to show you how. Okay. Okay, so hopefully our instance has been built.
Want to go back to the other tab?
I don't think it's
the
gonna.
tab, no? No, the middle one.
This one? No, this is just like a guidelines. So if you have any, so there is a good kind of tutorial also available on Unimul's CLAD website that you can see, okay, how you can attach like volumes. We can see that in action, but if you want to follow the recipe, there is also some material there. Okay, so here you can see that now an instance has been created, and this is the public IP address that you can use for connecting to your instance. You can copy this IP address, and if you want to change anything, so if you want to make a snapshot or backup of your instance, so you can click this one here, and it's going to create a snapshot of your whole operating system and every file that you included in that virtual machine. There are other like operations that you can do, so like assigning a floating IP, which you don't care for now. Attaching, detaching interfaces, or like editing the instance if you want to, for example, rename it or do other kind of modifications. You can also go here, like changing the security groups that has been assigned to it. Okay, so for now, let's go and connect to this virtual machine.
When you create a snapshot and you have a volume attached to it, do you also snapshot the volume?
Yes, that is a separate process. It is like making a backup of your hard disk. So it doesn't do it by default. So when you create a snapshot of like a virtual machine, it's going to create a snapshot of only the operating system and the storage which comes with the virtual machine. But then when you create a volume, then you have to make a snapshot of it separately. I will show it to you.
No.
Yeah, that doesn't back up. Yeah. Okay, so.
Can I have this snapshot?
Sorry, what?
How long can I have this snapshot available?
I think.
Until someone says that your Unimel allocation is come to an end, and then someone scrubs all clean.
Yep.
And then you'll find that there are publicly shared snapshots, or images that you can just use. Someone's created. It might be some bio, it might be some for different folks. And if Nectar or OpenStack decide these should be for broad people, it then becomes part of the drop-down list that's in there all the time. But for your assignment, this course, it's available for the lifetime of this assignment.
How many instances can you make?
It depends on the quota that has been assigned to you. So
you
now
do-
you're 4.
You are limited. So the students who are doing this course have the allocation I applied for was 4 medium VMs, 16 cores. You can't 8? 8. Okay. So that's exactly how many. If you try to exceed that, it's going to say
So
9.
8 cores and
4 instances?
4 instances?
Yep.
Okay.
If you wanted more, Well, in fact, you can't. You can't have
Yeah, you can extend it.
if you, I mean, let's say, I guess generally speaking, the accessing the cores and the virtual CPUs is where Nectar have not so many free. So there are literally thousands of people using Nectar and the Unimel dashboard, and there is a finite resource and many people are using it all the time. Storage is a different matter. If you need more data storage, and to be honest, for your assignment, you don't need more. So we're not asking you to crunch, terabytes of data where you need lots and lots of resources. You're collecting data, you're processing data as you're getting it and storing it into a database. And we'll take you through how to do that in the next lectures. But generally speaking, this is not a kind of, what your resources you have are what all the previous students and all the previous years had. And it was completely, it's sufficient for the job.
Are those resources per student or per team?
Per team.
13.
So every student, what you want to do, every student in a team has a mini PT1234, which is your own private little mini VM to play around with and explore. Every team has 8 virtual CPUs and 250 gigs of storage. And as a team, you might decide who's going to be the person that's setting up the server side and the infrastructure, who's going to be doing the dashboard and the virtual visualization of our data, and who's going to do sentiment analysis, and who's going to what scenarios tomorrow. So as a team, you decide these things. And someone generally is more on the DevOps / sysadmin deploying the system side.
Okay, should we continue? Yep. So looks like the Unimel Cloud is back, so I will continue using that one. As you can see, the instance that I created in Nectar is also available here. So basically, they are using the same infrastructure, but the UI is only different, okay? It has been like customized with the university's logo and everything. Okay, so before SSHing into the virtual machine that we just created, so let's go and see how we can create a volume and attach it to our instance. Then we can follow the next steps after accessing our virtual machine. So here, if you go to the volumes tab, you can see I've already created a volume here, and it shows you it has been attached to which instance, which was the test or the instance that I created before. So what I'm going to do is that I'm going to create a new volume here. Okay, so we give it a name. You don't need to define a source. So if you want the source to be an image, then you can specify that image. Otherwise, it would be an empty volume. And then you specify the size. Let's say 10 gigabytes. And the availability zone, as you can see here, so in Nectar you can select from a list of availability zones, but here the default is Unimob, so you cannot change it, and we will leave it. So I will say, okay, I want to create this volume. This one should be fast, despite the other one.
What does an image mean in the context of a volume?
The image?
Yeah, what does that mean in the context of a volume?
No, it means creating a volume from an image. So you have, for example, made an image of like whatever files that you have had, okay? And then you want to create a volume out of it. So it's going to appear as a volume to the instances that you want to attach, okay?
But that image doesn't contain an operating system.
No, the image can have or cannot have. So the concept of that image is different with the snapshot that you take from an instance, okay? Okay, so here we have our volume created. So what we need to do is now we go and attach it to the volume that we want, to the instance that we want. So we click Manage Attachments, and from here we select the name of the instance that we want to attach to, and then say Attach Volume. Okay. One more thing that we can review before actually logging into the machine is that we can go to the network section, and under here You can ignore the rest because most of them, even you don't have like quota to create like load balancers or those things. So these are like advanced topics, but the one that you need to use is the security groups. So if you click that, from here you can see that you have the option of creating a new security group. So you can just give it like a test, give it a name, and when you create it, you can actually define rules within that security group. So it can be any rule that you want to define. So this is the one that I just created. I click manage rules here. So you see by default it doesn't have any rules. It is just opening all the communications with the outside world. So I click add rule here, and let's say I want to open port number 80. Okay, so you type in the port number here, and then you say whether it is like ingress or egress, and whether it is like, you see this, the range of the IP address that you want to specify is also included here. So if you want to say, okay, I want all the connections to this port 80 to come from the Unimelb's IP address, then you can actually put the CIDR notation for Unimelb's network here, and all the other connections would be blocked. Okay, so if you add it here, so then it's going to appear here, and you know how to add this security group to an instance. So let's say if you want to open port 80 on the instance that we had, so we go to this instances here again.
So you'll get used to this with the cloud. It's not real time, it's processing, loading, and you might well have to try several times. Sometimes when it doesn't work first time, you have to wait, you try again, and you think, I didn't do anything different, but now it works. This isn't Amazon.
Okay, so you select the instance that you want to edit its security group and click the edit security group button. So here you can see these are the two ones that have been already added. So I want to add this new one here. That HTTP is basically the same thing but created by Nectar by default. But if you want to add it here, then you just add it and it's safe. So now the port number 18 is open on our instance. Okay, so that's it. Now we can go and SSH into the instance.
Well, that's not just, you said that by default when you create a new rule, it opens everything?
No,
Oh, okay.
opens all outgoing connections, not incoming connections.
Oh.
All the incoming connections are by default blocked. That's why you need to add that SSH and everything.
So with the incoming connections, if something comes in, is it necessarily allowed out?
No.
No.
Okay.
You have rules that allow things that can come in,
Yeah.
and rules that allow things to go out. Default
Yeah.
is you can access FTP, you can access SSH, you can access random things going out, coming in, SSH,
Yeah.
and you lock it down. And then you have to be very wary what you open up. So port 80, so you might have a web server, it's just like, I only need port 80 open.
Yeah.
But you don't want to have people being able to telnet. So, you
Yeah.
know, random services with random ports where they're poking you and trying to log in and do bad stuff. And that's kind of where if you don't know which ones to open, don't open them, basically,
Yeah.
is the default.
Because I know that like some cloud providers do, if you can come in, you can go out, like the same with the same connection, but we don't do that here.
It's a slightly different thing. I guess the reality is you can access any resource outside using all ports.
Yeah.
The things that can come in are very much restricted.
Yeah.
And you should be very wary what you open up.
But
And that's the same with Amazon. I mean, all of these cloud
no,
providers.
because they have rules where you can, if you come in, you can send with that same connection, you can go back.
There
out.
is a range of services that
Yeah.
can do these kind of
Yeah.
network address translation or
Yeah.
forwarding and things like that. In this, all you need to know is that
Yeah.
you have open access to all the ports going
Yeah.
out, and you've got to be careful what you open up for people coming in.
Okay.
And plus there are several levels of access control that you can implement. That is kind of like an IDS rule that you set. So you cannot control that here because that rules are being enforced by the firewall and IDS of the Nectar itself. But what you can do is that from inside the instance, you can use IP tables and those kind of things that comes with Linux. So you can just modify those accesses as you want.
Okay.
Yeah.
Cool. Thank you.
Okay, so now this part is done. Now let's see if we can, so we need to copy this IP address here. Yes?
These rules, they look like basically like two firewalls.
Yep.
Are they the real firewalls to our?
Yes, these are like opening a port from the Nectar's firewall. So that is like the first layer that you can access the layer. But as I said, you can also limit those access inside your virtual machine as well. So you can have multiple layers of protection if
So
you
there's a Nectar's firewall.
Yes.
And then it's,
So
Yeah.
what it is actually the OpenStack software has security components, which when you say, give me a virtual machine, or give me an instance rather, you can say, okay, we've created one for you now, it has some storage attached to it, and then you can say, and this is the IP rules, or how it should be open to the outside world. And there are services in OpenStack that you are used for that. This is literally just parameterizing, open port 80, because I need it. So when Farzad launches it, now we'll be able to access it. But this is all happening by services that exist within OpenStack Keystone is the service. We'll go into some more details about how they do these things later on, but this is just showing you how to drive the dashboard, I guess. You might want to make that bigger.
Yep, sure. Okay, so now we are going to access the virtual machine that we just created. So what we need to do is that I copied the address. So the default username for the Ubuntu-based instances is Ubuntu. But if you're using like other types of images as your base image, then the username is different. Okay, so because my key file is included in my SSH directory, so I don't need to specify like a path for it. But if you followed the creating a new keeper thing with like the test.pm file that I just created, then you need to pass an additional parameter, which is the location of the key file. And it is like this one, but then you add -i and then where the file was, okay, for accessing your instance.
the private key.
The private key, yes.
Excuse me,
Yeah.
we say it again, like, so is that if I create an operation system in Ubuntu, then you want to add that. If I create a Linux, then it's like CentOS, then I use.
Yeah, then the username is, no, it's not CentOS. I think, what is the default one? Root? No, it's not root. It is, I think, EC2? EC2? Yeah, maybe you can check the documentation. It is inside the Nectar's documentation. What is the default username? But for all Ubuntu base, and the Debian base is like Ubuntu, but for the CentOS and Fedora, it's something different. I think it is either EC2 or EC2 user, one of these two. You can check it online. It is inside Nectar's documentation. Okay, so now you just say yes to this one. And as you can see, we are now inside the virtual machine that you created. Okay? So what is difference with this virtual machine that we created with the HPC that you log in like using an SSH is that this virtual machine you have full access to. So you can install any software that you want. You can run anything on it that you want. So you are not just limited to the rules enforced by university's HPC anymore.
But you're being monitored, so don't do bad things.
Yeah.
You can install anything you want for the assignment. If you start trying to do port sniffing, or you'll be blocked straight away.
Yeah. Okay, so just to see, so if you want to install anything, so you just use the sudo, but you don't need any kind of password or anything. So you have full access. So if you want to, like for example, install Apache, here you can say, okay, I want to install Apache. Okay, the only remaining section is that I know Yalpan needs more time to cover his lecture, so the only thing that I'm going to do is that show you how we can format the volume that we just attached to this instance and then use it. Probably I'm going to skip this if I can. Okay, so if you do a you need sudo. So if you use the fthis command, you can see that the volume that has we created, that 10 gigabyte volume, has been like attached to here /dev/. VDC, okay? But what we need to do is that first we need to format it. So we use this command, make file system ext4, and then it might appear sometimes under a /dev/vdb, so be sure to just check it where it has been like attached to. So now the volume has been formatted, and now we can just now mount it to our system. So if I do like a df-h, you can see that there is no mention of that 10 gigabyte volume that we created because it hasn't been mounted yet. Okay, so now we are going to mount it using this command. Oops, let's first create a directory. So first I created a directory, and now I'm going to mount the volume inside this directory. So it's going to be sudo. Yep. And now if you do the df-h, you will see that the 10 gigabyte file, the 10 gigabyte storage that we created, is now appearing here. The reason that we need this kind of storage is that the default storage, as you can see here, I've got like 30 gigabytes here available to me under /dev/vdb. But the thing is that if you like delete this instance, or even if you like restart it, then all the data which is inside that, it's going to be clear. Okay, so this is what they call it, ephemeral storage. So you need to create those volumes and attach it to your instance so that your data doesn't go away. But the only problem with this approach is that now if I restart my virtual machine, that mounting is going to be removed. So you need to remount it again. Your data is going to be safe, but the mount is going to be removed. So what you can do is that, and it's also described here in the documentation. Here, if you go here, you can see that what you need to do is that you need to modify the fstab file here. You see, it is under etc fstab, and you need to add this line. And in our case, we need to replace this VDB with VDC. And then what happens is that every time you restart your virtual machine, it's going to automatically mount that directory under the one that you define. Okay, so I think that's all from me. So in the next section, Yaopan is going to show you how you can use Ansible.
All right, so that's kind of a quick sort of. Okay, folks, we're on again. So now you've seen how the dashboard works. Now you're going to learn how to automate all of this so that you don't need a dashboard ever again.
In this workshop, we are going to see how to automate the process Father just did through the dashboard. So you don't have to manually click through all the buttons and wait to create the instances. So there's lots of solutions available on the market to automate the process. But first, let's see what's the benefits of using automation. So imagine you have many servers on the cloud, which running the Apache server, and you want to update the server to the latest version. So what you're going to do without the automation, you have to manually SSH in each server, then check the version of the Apache server, then update it. But how about, you may be able to do it for 20 or 30 servers manually, but how about 100 servers or 1,000 servers? That's almost impossible for you to do that. Then that's when the automation kicks in. So automation can do that for you. Instead of doing it manually, one by one, they can do it automatically in batch. When people develop a cloud system, often there are many dependencies you need to install, and you need to remember how to install them. But after a couple of months, when people ask you to deploy the system again, you probably forgot what exactly needs to be done to get the system work. But if you have created an automation script, each step for the deployment will be documented in the script as lines of code. So you can always go back and check the script to see what exactly needs to be done and how to do it. The manual deployment also has a problem. It's error prone. So it involves human doing stuff so people can make mistakes. But automation requires less human input, so it will be more repeatable and less error prone. Some people will ask, how about snapshots? Snapshots can certainly help in some ways, but snapshots are more like pictures. So they capture the system state at a given time. But it won't tell you how can the system reach that state. It won't tell you over the time what the changes are. But automation scripts like computer codes, so you can check into the Git repository. And you can always go back to check into the history, see what have been done and why you did this. There are 3 categories of the scripting tools. We usually categorize them into 3 categories. The first one is cloud-focused scripting tool, which will only work with cloud services, such as CloudFormation or OpenStack Client. The other one is shell script. The most famous ones are Bash script and Perl script. The third one is the one we are going to discuss today, which is the configuration management tools. Configuration management refers to the process of systematically handling the changes to a system in a way that it maintains integrity over the time. So in fact, automation is the heart of the configuration management. It helps you to quickly provision servers or quickly recover servers from a critical event. It also can help you to quickly replicate the environments. In this workshop, we will focus on Ansible only. So Ansible is a simple automation language. It's easy to learn and self-documenting. It supports ad hoc task execution and the configuration management. What does that mean? It means when you need Ansible, you can create some script called playbooks, and you can ask the playbooks to run certain tasks against certain servers to do something for you. It is like a programming language, so you can have a try-catch clause in the Ansible script. Then if any specific error happens, you can handle it accordingly. Here are the features of Ansible. I'm going to skip these. But one thing I want to mention is Ansible playbooks are expressed in YAML, and the templates are in Jinja too. So if you are not familiar with these languages, you can go to the links here. It's very straightforward, very easy to understand. If you read the document, you should be able to master them. How about the installation of the Ansible? For Linux and macOS, it's quite straightforward. You can just follow the recipes on the slide. But for Windows, it became a little bit complicated. Just now, a student just asked Father about how to SSH in to the VM via Windows. What my recommendation is you install something called WSL, Windows Subsystem for Linux. Basically, you can install Ubuntu inside Windows. There's a link here, which is a YouTube video. It can get you through how to install the WSL and the Ansible on Windows. Otherwise, I think if you use PuTTY or other software, it sometimes became troublesome. Here is how the Ansible structures look like. You can create a simple folder for it, which is the playbook folder. Inside the folder, you can have some YAML files and some configuration files. And there are a few sections you can have inside this folder. The first one is variables. Obviously, it defines all the variables you are going to use in the playbook, such as the port you want to open or the software you want to install. The next one is inventory. Inventory defines the hosts that the playbook has access to. So here is an example of the inventory file. So you can see there are IPs or domain names. You can even put host names or even put a range of IPs inside here. Then you can group all the hosts into groups. There are 2 groups on the example. One is web servers. The other is DB servers. So what can the groups help? So say, for example, you can say for this row, I want to run on all servers. And for the other row, I'm only targeting the web servers. And the third row, I will only do it for the DB servers. So you don't have to specify the hosts one by one, but you can just say for which group. The next will be the rows. Rows are like modules. It breaks a complex Ansible playbook into pieces, so you can reuse each row. So basically, the demo you're going to see, I took the rows I built for something else, but I can easily just grab it and do demonstration here. So inside the rows, you can have another layer of folders. The first, it can be default, so you can put all the default values for the variables inside here, so you don't have to specify the same variables if you just want to keep it default here. Then the next one will be the tasks. The tasks are the actual thing you want the Ansible to do. Say, for example, the task 1 can be install Apache, and task 2 can be restart the Apache service, etc. Then the next one is the templates and the files. There's slight difference between the templates and files. So the files, if you use files, it will be uploaded to the host as is. Whatever you put in this folder, it will just be uploaded. But for the templates, it's defined by in the Jinja 2 language. So all the variables you define in templates will be replaced by the actual values from your variable file. Then it will be uploaded to the host. It's very useful for uploading the configuration files to the server, such as Apache configuration files. Every time you will have different configurations, and you can specify the variables here. The last one is the playbook file itself. So it defines the configurations, the deployment, and the orchestrations in Ansible. Here is another structure, another way you can structure the Ansible playbook. It is useful if you want to run a simple task against a large number of servers. So first, it defines what host is going to targeting. So in this case, it's going to run on all the web servers. Next, it defines the variables, which the package is HTTPD, which is the Apache server. Then we have 3 tasks here. The first task is to install the latest Apache server onto the host. So we have the variable here. So the variable is surrounded by the curly brackets. But be careful, if the variable is the first element of the value, you have to surround it by the quote again. Otherwise, Ansible will tell you something wrong. It's a very common error from previous years, so be sure you put the quotes here. And the state is latest. That means we want to install the latest Apache server. But you can say, I install which version, say, for example, 1.0.0, then you can say HTTPD equals to 1.0.0. You can't specify from here. If you specify here, say absent, which will remove the Apache server, so it's uninstall. Then the second task is upload the Apache configuration file from this location to this location. So from your local location to a remote server. The third task is to restart the service. So we use the service row here, and we restart the Apache service and make sure it's restarted. See, from this inventory file, you see it's a range of the servers. So you can do from www.01.example.com to www.50.example.com. Or you can specify a range of IP addresses. So remember, we just said about how difficult it will be to update Apache server on hundreds of servers manually. This simple Ansible playbook does exactly the same thing. Will help you to update how many servers here, like 304 servers here, in probably 10 to 20 minutes. But if you want to do it manually, probably takes you maybe days to finish. Don't worry if you are not familiar with the Ansible syntax. On each slide, I will link the module to the Ansible document. If you click this link, it will link you to the Ansible document, which is very well documented with good examples. So if you can quickly go through each module, it will help you to understand the syntax. So for the first demo, what we are going to do is we are going to repeat what Faza just did. First, we connect to the Melbourne Research Cloud. We list all the images available on the cloud. Then we create volumes. Then we create security groups with security rules. Then we create an instance and attach the security group and the volume. And last, we create snapshot of the volumes. But before we doing this, we have to download a couple of files from the dashboard. So first is the openrc.sh file, which defines the, all the variables you need to interact with the OpenStack API. The file will be look like something like this. So it defines the endpoint. Oh, you can't see? Okay. It defines the endpoints here, the project IDs here, and the project ID, the username, stuff. These are the variables you need to interact with OpenStack API. But be careful, make sure the correct project is selected, as this file is project specific. If you accidentally on the page of the PT project, then you won't be able to create any resources. Just make sure it will be the project Richard creates for the assignment 2. The next one we need to grab from the dashboard is the API password. So if you follow this link, dashboard, user, then go to settings, then reset password, then click reset password. So the password will be printed here. You just need to copy it and save it in a safe place. But if you forget, it's okay. You can just always reset it. The next one is we need some variables to be defined. First is the flavor. So you probably can only use this one because you only have 8 cores. So to create 4 VMs, you have to grab this flavor, which is 2 core 8 gig. And for availability zones, there's only one, so QH2 UAM. For the image ID, this is the image Ubuntu 16.04. If you want to use other images, that's fine. Just follow this path, dashboard, compute, images. Then you can search what image you want. Then click the drop down, and you can find the IDs here. So now let's have a look how to run the playbook. So here is how the playbook folder look like. First, I define the variables here. Here's the availability zone. I define some volume, the volume name, the volume size here in the dictionary. Then I define security groups here, the security group name, the description, what protocol. This is pretty much for the rules and which port to open and open to where. Same as here, I open the port 80 to everywhere, but it's not a good idea to do this, as you don't want to, everyone can access your SSH. So usually you should do something, say for example, if you want to only from Unimail, then you should do something like this. So only the IP addresses from Unimail can access this SSH. But just for the convenience sake, I put everywhere for the demonstration. Then define the instance name here, and the instance image here, the instance key file name, which is my private key, or the public key here, and the flavor here. Then let's have a look at the rows. The first row is common. So what it does is I use this row to install some dependencies to run the OpenStack. So first one is install pip. So pip is not coming with Ubuntu usually. So I have a condition here. So if I check the host OS is Ubuntu, I install the Python pip here. It's equivalent to this command, sudo apt-get update to update the cache. Then I install Python pip. Then the next task I have here is to update the pip to the latest version. So it's equivalent to this command if you run from command line. And the last one is the most important. I need to install OpenStack SDK, which is required to interact with the OpenStack API. The next role I have is to grab all the images from the OpenStack Cylinder API. I use the OS image facts module to grab all the images from the OpenStack API. Then the next task I'm going to do is I just loop through the output of this task, then loop through and grab only the names and IDs, and I put into a dictionary, then put all the names and IDs into a list. Then I can specify I only do this when item.name is defined. Otherwise, it will skip. Then the last task I'm going to do is just to simply going through the artifacts from this step and print out all the image names and IDs. The next role I have here is to create an instance. So I have all the variables defined in the variable file, but some of the variable will be the result from other roles, such as the security groups. It will be a list of the security group names, and the volumes will be a list of volume IDs. Then I say I want to get the IP address automatically. I want to wait. The reason being is usually Ansible going like from top to bottom. So one task by the other. If the previous task fails, it will fail. But for this OS server, it's kind of asynchronous. So it just make an API call. Once it says I receive a successful 200 from the API, then we'll move on. But the problem is Nectar needs time to create the instance. So we put a wait here. So it will be waiting until the instance is created for the maximum 10 minutes before we move forward. The reason being is we need the result to get the IP address. So the following tasks is depending on this task. So we have to wait. And again, the state is present, means we are going to create the instance. If we want to delete the instance, just put as absent. After running this, the OpenStack API will return a JSON object, including all the details for your instance. We just register this return value as a variable called OS instance. Then the next step, I just simply go into this variable and get the IP address from the instance and print it here. The next one is to create a security groups. It's quite similar. So I use the OS security group module to create a security group. And because in the variable file here, I defined a list of dictionaries. So here, I'm just going to loop through the dictionary and use the name from the name and the description from the description to create a security group. After creating the security group, I just loop through the same variable just to grab the names and put the names into a list. This is required to create an instance in the OpenStack instance role. Then I simply print out the security groups I created. Then similarly, I just create all the security rules inside each security group from this role, or this task. For the volume, it's quite similar. Just going through the variable here and put the volume name here, the volume size here. The availability zone is also defined in the variables. Then I just going to create the volumes. Also, I wait. Then I register the output as OS volume. Then going through the OS volume return value, grab all the IDs, and I print IDs. And the same variable will be used here to attach the volumes to the instance. The last one is the snapshot. So I'm just going through the same volume variable, grab the names, and I put the name plus the timestamp as the name of the snapshot and create a snapshot. Again, I will wait until the snapshot is created. So here are the rows we are going to use in this demo. Then let's have a look at the actual playbook file. It's quite simple. So because I don't have any server yet, so I need to use my computer to run the Ansible file, then interact with the OpenStack API to create these resources. So the host will be localhost, and I specify the VAS file is the file I created here. Then just say gather facts true. What it will do is it will gather the facts from my OS on the host. Then it can say, oh, you are using Mac, so I don't need to run this step. If you are using Ubuntu, then it will run this step. So in the rows, I just run the rows one by one, but there's some dependencies, such as the instance depends on the volume and security group, so it will be later, as it will be the same from top run to the bottom. Then the last one we are going to see is how to actually run the playbook. So first, we need to source this OpenRC file, which has all the variables here for interact with the OpenStack API. Then I just say Ansible-playbook. Then I need to ask the sudo password because we are going to run some commands as a super user. Then we specify the playbook file. So let's have a look how we are going to run this. So if I just say run Nectar, then it will ask me for the OpenStack password, which the password you get from the first step, the reset API password. Then it will ask you for the sudo password. Then first task, it will gather the facts, which is gather all the facts from my computer.
Do you have are you going to load that onto Blackboard, what you just showed us?
No. Because there's something you need to figure out for your assignment too.
For the demonstration, all
Yeah.
the links that says here's, I mean, what Yaoban's just gone through there, all that's documented. So you don't have to think, you just gave me 27 different scripts that all do different stuff. Each one in the presentation,
Yeah.
there's a link saying this is what, how to do step A and step B in the Ansible documentation.
Okay.
So as you can see, I already gather all the facts from the OpenStack API for the images. Then I'm going through all the images and print the name and the ID one by one. Then I have created the volumes here. Note there's some color difference. One says changed, one says OK. They all mean the task is successful. The difference are some tasks you just get information from the remote. Then you don't need to change anything on the remote. But some tasks you will change something on the remote. So if there's something changed on the remote, it will say changed. Otherwise, it will be say OK. If there's error, it will say error. Now you see error. I'm not sure if it's related to the Melbourne Research Cloud problem.
It's trying to network.
Oh, okay. It's actually created, but somehow it's in the error status. So I'm going to delete it and try again. So welcome to the cloud. Especially the free cloud. I'm pretty sure if it's on Amazon, it won't, at least not that often.
Is there a concept of a transaction there? If a large script fails on the 50th machine out of 100, does it roll back the first 51?
No. So what's done is done. But what you can do is when you run it, you just specify like a dash VVV. It's like a verbose, so you can get more information from the API to see what exactly was wrong.
So you said Ansible is compatible with other cloud platforms like AWS, right?
Yes.
So we can take this and just use it with AWS with no modification?
AWS, there's another sets of modules. If you notice, it's this sets of modules I used start with OS, which is OpenStack. But for AWS, you will use EC2 modules in the Ansible. You can search on their document. They have detailed document about how to interact with AWS.
So we just need to change that one?
Yes, syntax will be slightly different because AWS has more layers when creating a new resource. Say, for example, they have VPCs, they have security groups, but on Nectar, they only have security groups. They don't have these PCs. So it has more detailed stuff you need to create. I hope this time I can create an instance. Yeah, it's created, and it's printed the IP address here. So now it's taking the snapshot of the volume. So if we check back on the dashboard, so the server has been created. And also we can see the snapshots, and you can see the volume has been created as well. Also the snapshots. So here is demo 1. So for your assignment 2, probably you have to create something similar to this. You will provision like 4 servers instead of 1. So what I did is I put up a quiz page here. So if you can try out these yourself, along with the one I just demoed, when you get the project, I think it will help you to go through your assignment 2. I put some hints here, but if you have any questions, you always can ask on the discussion board. So the next demo I will do is to use a simple playbook file to deploy a WordPress stack with Docker. It's okay if you never heard the name Docker before. We will cover this in the next workshop. But for this, just to demonstrate how easy Ansible can do to deploy stuff. So again, I have all the hyperlinks here. If you want to know the detailed syntax, you can just click the links. So just let's quickly go through the playbook again for this one. So this one is much simpler. It defines, so first thing I want to do is actually easier from here. So I will install some dependencies. Then I'm going to mount the volume and make the file system just as Father just did. Then I'm going to install the Docker on one of the volumes. and we're going to deploy WordPress with Docker in another volume. So I defined the volume device name and the mounting point here. And I defined the WordPress working directory here and the database, the details for database here. Then for the roles, it's similar. So the common role, I just install all the dependencies we may need to run the server. Then for the Docker role, I just going through the official Docker document, then translate the command line language to Ansible playbook. So we're going to uninstall the Docker if there's any Docker installed before, then install the dependencies, then add the apt repository key, add the actual apt repository, update the cache, install Docker, and install Docker Compose. Then for the mounting part, the same, we're going to install the dependency as I'm going to use XFS instead of ext4. So I need to install the XFS package here. Then we are going to make the file system just like format the device. Then we check if the mounting point exists. If not, then we are going to create the mounting point here. Then at the last, we mount the volumes into the device, the instance. Then the last row is to install the WordPress. So what we need to do is just create the WordPress working directory. Then I'm going to use the template to upload the Docker Compose file, which is a simple Docker kind of orchestration tool to the remote host. So in this Jinja template, we have the variables we defined in the variables file here. So it will be, when it uploaded to the remote host, these variables will be replaced with actual values in the variable files. Then the last, I'm just going to run the Docker Compose. So first thing I need to do is I need to replace the host file with the IP address for the instance I just created. You don't have to take a picture of this one, because I'm going to nuke the server very soon. Then the next one is how do I run it? So it's the same. First, I source the OpenRC file. Then I specify the inventory file, the user, the SSH user, which is Ubuntu, and my key file, the private key, then the actual playbook. Before that, I need to show you the actual playbook. So the playbook is very simple. So I say the variable file is here. I'm going to targeting the group called WordPress. But I have a pre-task here. So sometimes when you create a VM, it doesn't have Python installed. Then the Ansible is dependent on Python. So if you don't have Python installed, Ansible won't run on the VM. So you can define a pre-task to install the Python first before you actually run the roles. It's very useful because all the images on AWS are vanilla, so they don't have anything installed apart from Ubuntu itself. So you will need this pre-task, especially when you are going to run on AWS. Then we are going to run the rows one by one here. So let's have a look how easy it can be. So I'm going to install the Python 2 on the server. Then I need to gather the facts from the remote host, because the Docker role requires some details of the OS, so I need to gather the facts from the OS. Then I'm now installing the dependencies. It takes some time to do this part. Now I'm updating the pip.
So is there like a main file that's holding everything together and pointing to all the other files? Because you had a bunch of files open.
Yes,
Yeah.
so that's very important. of these structures. So
And then when you're running that file on there, that's
Yes.
why it keeps going through all the tasks?
yes.
Okay.
So this names is actually keywords. You can't just, oh, sorry. These names are actually keywords, so you can't name it row, it won't detect. You have to be rows. And in the rows, it has to be, say for example, tasks.
Yeah.
Then these are actually the keywords. That's why you need to stick with the hierarchy.
I guess it's all defined in the playbook.
Yeah,
You define the variables, you
Where's
give
the
the names for the
playbook?
servers, you give all the
This
kind
is the
of
playbook.
information.
And what's it called? Yeah.
So effectively, you're developing, I mean, Ansible is about as simple as it gets for scripting. I mean, there's much more complicated languages which have, it needs to be more of a sysadmin, I guess, to be able to do it. This is a sequential way. You define a few variables, and then you're building it up, and at the end, you say, run this playbook. The YAML file defines all the things, and if you don't define something and you try to use it, it will complain and let you know.
So here it will know that the rows are common, so you then called something common?
yeah, because I have the common folder in the rows.
Okay.
So if you see these are linked. So common,
Yeah.
right, Docker, here. Then I have volumes here. And last one is WordPress.
Okay.
So it's linked. So you say rows, it will go into the rows folder to find these rows. Otherwise, it will say, I can't find this row.
So where's that playbook located?
It's in the root of this folder. So if you can see from here, here's the playbook. This
Okay,
is the,
so then when you're in that other screen, you just type in run this
Yeah.
playbook and then okay, cool.
yeah. So
Could you please say, what is the editor of this?
edit.
Yeah.
Oh, you mean the edit?
Yeah.
It's VS Code. You can use any editor. So now the WordPress has been installed. If we go to the browser, then you can see it is installed. So you can see with the power of the automation tool, such as Ansible and Docker, I managed to create a resource and deploy a WordPress stack within, say, for example, 10, 15 minutes top. But if you want to do it manually, I would say probably half an hour to an hour to do this at least. So it won't save much time for a simple task. But imagine if you have a complex task, and imagine you have hundreds of servers you need to deploy. Then Ansible and the other automation tools can help you a lot to save the monies and also the time, and also you won't make any mistake because it's like a pipeline, like a machine. It's keep doing the same thing again and again and again. It will never make mistakes unless Nectar has some issues. So for the next section will be the, yeah.
In the previous demo, you enter twice the password.
Yep.
So what are they?
The first password is the API password. So, so you get from here. So you get the sudo password is the password for my computer.
So the local laptop.
Yeah, the local laptop password. Any more questions? No. So the next section will be the Git. We will cover.
Maybe just one, just to let you know, I mean, for those who don't get, you're welcome to stay, but you can also leave. Just for your assignment, just to let you know. So, obviously I'm not going to give you the second assignment just yet. You're probably not going to like me if I do, but I might do it anyway just so that you can all see what's coming. But generally speaking, what you're not going to do is say, dynamically deploy your system, the whole thing. What you're probably going to do is demonstrate how you can spin up an instance, deploy your software which is going to connect to Twitter, collect the data, do the analysis of the data, and then connect that instance and all the software to your database which you're collecting. So it's like this. So imagine now, if I said your application has to run across 1,000 machines. You're not going to have, you have a few instances that you can play with. and a few CPUs, but in principle, you should be able to demonstrate. If you wanted to add more Twitter harvesters, you could easily, just by changing one script in the file. So that's kind of the idea. It's not about, you're not going to install, what Yao Ban did here was install a brand new system, WordPress, on an instance, etc. For your assignment, you're going to build a system, you're going to have your couch database, you're going to have a web front end, you're going to have things connecting to Twitter, but then what you need to demonstrate in your assignment, the second assignment is, in principle, we could dynamically deploy a Twitter harvester to connect over there, do stuff, and then it's integrated into the other system. And that is the basic idea behind what you're going to be doing. Understanding how it works is the beginning, but that's kind of the general intention. And not everyone in the team needs to do this. So you might need one person in the team that's going to be Mr. or Mrs. Ansible, for example. That one person who understands all the syntax here, and I generally recommend everyone does it because we can kind of ask questions in exams on all this stuff. So don't think because it's implementing X or Y, I'm not going to ask you about Twitter data or things like this, but if it's being taught in the lectures, it's kind of examinable. If we're showing you syntax for writing Ansible, or we're showing you dashboards of Nectar, or when we get into the OpenStack components, all that's, if it's presented here, it's examinable. So just to let you know, just don't think, okay, only Fred needs to learn Ansible, because Fred's going to get an H1 and you're going to fail. Okay, so as I say, if people want to have a, if you're happy to stay, if you know Git inside out and you've got stuff to do, feel free to go. Obviously, none of you have done Git, or you're just super keen to learn more. Sit down. I'm joking. You're allowed to leave, honestly.
You just give 2 minutes.
Do people want to? Shall we just carry on, or do you want to just go straight into it? Or have a 2-minute break? Okay, let's take a 2-minute break, and then we'll start again.
So 15 minutes?
Yeah.
Okay, so probably YouTube. So, in this workshop, it doesn't work anymore. Is
it on? Let me see. There's a button inside. Battery's not charged.
No battery. Oh. In this workshop, we are going to quickly go through the basics of the Git software version control system. So what is Git? Git is a distributed, which is decentralized version control system for tracking changes in source code during software development. Then why Git? So first, Git can keep tracking the changes. So Git keep history of the changes, which helps the developer to go back to the time to understand what the changes are, why you made these changes. The other thing is you can revert the changes, or you can go back to time, check out source code at a given time. So for example, you did a major refactor to boost the performance of your code. Then after the refactor, you want to see how much performance increase. Then you can go back to 1 month ago from the Git, build the software, run it, then come back again, then build the software, run again with the refactored code, then you can see the performance difference. Without Git, then you have to physically copy have a copy of the source code a month ago. Then you have to run from there, then run from here. But with the Git, you can always go back to the history. It's like time travel. The third and the most important benefits of Git is you can be able to work with people. So a group of developers can work together on the same project, on the same file, even on the same code block. Then you can work simultaneously on the same thing, and the Git will handling the challenge of merge the code together. But you may need to do some handling some conflicts, but Git will do most of the job for you. So Git is not the only VCS available, but by far it is the most popular. The others like SVN or CVS. But one thing I want to mention is Google Drive or OneDrive is not VCS. I saw a lot of students, they use Google Drive as Git alternative. Then they fight on the tutorial because user A override the user B's work. Then they fight who did this. But be careful, Google Drive is not the way for you to share the files because it's not built for software development. The bottom part, sorry. Here is the major Git service providers, such as Bitbucket, GitHub, or GitLab. For this demonstration, we are going to use Bitbucket. And here is how to install Git. Again, for macOS and Linux, it's quite straightforward. You can just follow the recipe here. For Windows, help yourself, just Google it. If you're too lazy to Google, you can click this link. Okay? There are some terminologies I want to quickly go through, such as repository. Git repository is a collection of commits, branches, and tags. And what is a commit? Commit is just same as you save a file. But the Git way to save a file is a little bit different. It will not only save the change, but also will assign a unique hash to this change, which also include who made the change, when did you make the change, and what the changes are. A branch represents an individual line of development. So it's kind of a snapshot of the main branch. So you have a main branch, usually called master. Then when you're branching out, you create a snapshot of that branch. Then you can work on the snapshot. Won't affect other people work on the main branch or work on the other branches. A tag is more like an alias to the hash. So you can create a more human-friendly tag name for this hash. Say, for example, usually we tag it with version number. Say, for example, 0.1.0 or 1.0.0. Git a pull fetch the change and merge into your working branch. And the push will sending your change to the remote branch or the remote repository. Remote is a version of something hosted on a server, such as Bitbucket or GitHub or GitLab. You can also host your own Git service. There's you can host your Bitbucket or some other not open source, but commercial Git service. For merge takes change from one branch and merge into another branch. And the rebase is, I think, the most complicated. So easier for me to show you in the diagram. So say, for example, you check out a branch from here, from this commit, then you create 2 new commits here. That's on your feature branch or your working branch. Then at the same time, the main branch going forward. So when you are ready to put your code into the main branch, you are behind the main branch. Then at this time, we need to do a git rebase. What it does, it just take this head and forget about this head and move your head from here to here. So basically, you move these 2 commits here. So you're always on top of the main branch. But in this process, you may have to deal with some conflicts because the same the same code, the same line can be changed by the other people already. So you need to sort out the conflicts. So let's see how the Git works at a glance. So say, for example, you have a Git repository of shopping list. So you want the milk, the eggs, and juice. That's on your main branch. Then user A say, I want to modify the shopping list. So he check out. By checkout, he make a local copy of the main branch on his local computer. Then it will be exactly the same as it was on the main branch. He named it feature 1. It's on the local. Then he decided to remove the juice and put soup here. Then at this time, he has two choices. One is commit, so commit the change and save the change, or he can revert back to the original state. So this user decided to commit the change. So the feature branch, so the local branch became milk, egg, and soup. Then he pushed to the remote. So the remote has the same branch, which has the milk, egg, and soup in the shopping list. Then he decided to create a merge request or pull request to merge his change into the main branch. Then when you do this, you create a pull request. Then other people can review your pull request. If everyone agrees, then you can merge back to the main branch. Now the main branch became milk, eggs, and soup. And the version is 0.1.1. Not long after, the user A check out the branch, user B also check out the branch. So he has the same thing from here, milk, eggs, and juice. He did something different. He added an apple to the shopping list. Note, the juice is still in the shopping list. Then he committed the change and pushed to the remote. So now you can see there's a conflict. Because in the remote now, it's milk, egg, and soup. But here is milk, egg, juice, and apple. They're missing soup, and there's one more juice here. Here's the time he needs to do the rebase, which basically synchronizes the change from here to here. As simply, this user only added apple, didn't change any other things, so he won't have a conflict. All he needs to do is forget about the top three because he didn't touch it, just add an apple. So now his working branch became milk, eggs, soup, and apple. Then he created another pull request to push the change to the remote. Now the remote, or the main branch, has the latest version of the shopping list, which contains milk, eggs, soup, and apple. Then he can tag it as 0.1.2. That's basically how Git works and how Git can work with multiple people at the same time. So next is how Git branching working is same as this. So when you do this, you create a new branch. So branches diverge from the main line of development, so it won't have any influence with other people's work. So you can make a snapshot, you do your job, then you merge it back. There's some special names for the branches. First one is the main branch, usually we call master. And we usually also have a development branch called develop. So what's the difference? The master is always the release, not the release, the most stable release. And the develop is always the edge of your development. So all your latest change and code will be in the develop branch, but the stable release will from the master branch usually. Then we have other branches, such as feature branch, which when you want to add a new feature, then you create a feature branch. A bug fix branch, when you want to fix a bug, then you create a bug fix branch. So this will be bug fix / something or feature / something. These are all working branches. When you want to make a release, then you create a release branch. Say, for example, release / 1.0. The reason being you want to make a release is sometimes you release software, then you want to make a dramatic change on the code, which won't be compatible with version 1.0. As you are going to 1.2, it's a major release. It's not compatible. Then you can never merge this branch into the new development branch because the code base has dramatic change. But you still need to maintain this branch. As people will find bugs, you need to fix the bugs. So you want to create a release branch, it kind of fork out. Then you can keep working on the main branch, and at the same time, you maintain the release branch. And if anyone have any bugs found in the release branch, then it's called hotfix. Then we'll hotfix the bugs on the release branch, and sometimes it will apply to the main branch, sometimes it doesn't, because maybe the main branch already fixed the bug. By the way, these are just naming conventions. The actual branch are the same. It's just you name it differently so people can understand. So these 4 kinds of branch names, it's just the difference are only the names. There's no feature difference inside these branches. Yes?
Can we go back to the previous?
This one or this one?
Yeah, last one.
The previous one? Yeah.
What if the user
Modify what? Modify juice as well.
Yeah.
They need to fight.
I'm sorry.
You need to fight. Who takes the latest?
You have a conflict.
Yeah, you have a conflict.
So in flags, there is a conflict, and then how do you resolve it? Someone generally is like a sysadmin who identifies this, and then the team discuss, and then they agree and say, okay, we're going to have juice or not have juice, etc. So the software doesn't fix it for you. It's kind of the teams have to discuss. And also flag as well. It's very useful for everyone to use this kind of tech in your assignment. Because when you finish at Uni Melbourne, you're going to use it. I mean, it will be one of the kind of, you're going to work in a team, you have to understand. Don't just develop all the code and then just dump it into Git right at the end and just have one admin do it. Everyone should learn how to commit and things like this.
So this is a simple workflow. So basically, you make changes. You add a change to the index we call stage. Then after that, you commit to the branch. So how to add the files? So say, for example, you changed a file called readme. Say, for example, you just add the readme file. Then say commit. I add a readme file. It's just like a message, human readable message for you and for other people. Then you can push it to the remote branch. Or you can, there's two ways to push. One is you always specify where the remote is. The origin is the remote, and the feature / demo1, say for example, is the branch on the remote. So by default, the first remote will call origin. And the other way is you can set the upstream to this remote branch. The benefits of doing this is if you do this, then next time you just need to say git push. It will go straight to this branch, instead of every time you just type the full command here. So for this demo, we are going to create a repository on Bitbucket. So if you don't have an account, you can register an account on Bitbucket. It's free. Then let's just see the demo. So I have already logged in. I can create a repository from here, repository. Then I also have a project called comp9024. So project is something special in Bitbucket. It can group the repositories together. So I think it's useful for you guys for assignment 2 because you will develop the front end, the back end, the database stuff. So you can put all the repositories in one project folder. Then say, for example, the name called demo2. Our flag is a private repository. So only you or anyone you authorize can access this repository. Then go to the advanced settings. Say, I create this with a README file so you can see. So you want to have the issue tracker. So if you have issue tracker here enabled, it will be also helpful. So one of you guys in the team can act as a project manager. So they create the tickets. So say, for example, we need to create a UI. We need to create a backend. We need to do a databasing. Then you create the tickets. You can assign the tickets to different group team members. Then you can create branch from the tickets so you can have a track of your progress. So we click create repository. Then you can see the repository has been created. But this one will be on the remote. How can you work on your local computer? You need to do a git clone. So you can copy this command from here. Then just go to your local computer and just paste it here. It will clone the repository from remote to your local. Then you have a local copy of your repository. So if you can see, I already have that README here, and I'm on the master branch. Then from here, you need to create a working branch. So what you can do is git branch, git checkout, -b, create a new branch. Say, for example, called feature 1. Then you can create another branch called 2. Then you can switch between the branch like this. Then if you want to delete the branch, Then if you want to get a list of the branch, you will see there's only 2 branches left. Oh, maybe too small. Next, we will going to make some changes. Say, for example, I'm going to change the README file. Just say I made some changes here. Then you are going to save it. Then you can see if you do a, yep.
How to active and make and save.
Oh,
Yeah.
for Vim?
Yep.
So you just escape,
Yep.
then do WQ. W is save, Q is quit.
Yep.
Then after you change the file, what you want to do is you want to edit the file, which stage the file. Then you can commit. Then you can push it to remote. So as you see, if I just do git push, it will ask you where's the origin. So you can either do this to set the upstream, or you can just do git push origin feature 1. It has been pushed. So if you go back from here and check, there's another branch created called feature 1. If you check here, I made some changes here. Then if you're happy with the change, what you can do is you can create something called pull request. Then you can say, I want to merge the change I made from feature 1 to the master branch. Then if you have multiple people working on the same project, like your teammates, you can add the people from here. So they can see your pull request and they can comment on the change if they're happy with it or they have questions about it. Then you can either fix it, or if all of them approve the pull request, you can merge it to the master branch. So if you can see, it's highlighted here. I removed an empty line here. I added a new line here. So if everyone's happy, they can click approve. Then after approve, you can click merge. Then now if you go back to the master branch, you can see there's one more commit I added here. I changed some file. Then if you go to the source, of the README file, you can see the line is now in the master branch. Yes?
So after you merge
yep.
Like 2 branches, then you can never go back to the original one.
I can. I can. There's several ways to do that. First, you can rebase. Rebase also does is go back to the time. So you can rebase to another time. The other way you can do is you can check out from this commit. Basically, you can create a commit from here to another branch. So it's not actually exactly go back, but you create another branch based on this commit. After this, then if you go back to here, you go back to the master branch. If you do a git fetch, which pulls all the updates, it just fetches the updates. Yes?
So what's the difference of those? Maybe merge strategy?
The merge strategy?
Yeah.
So basically, this is a bit advanced. So basically, there's a couple of differences. Either if I use this picture. Okay, now I don't know how to put this back. Okay. Whatever. You can still see, right? So use this picture. This is what we call fast forward, which means it's always following one line. But you don't have to do this. This is just make the commit history much cleaner. So you only have one line, and the tree is always straight, unless you have another branch created, but the branch will eventually disappear. The other way is you can do like this. You can go from here, then commit to here. Oh, there's no cursor, sorry. So you can go from here, then commit from here. What it does is you actually commit from here, commit to here. So you commit, you create another commit, merge commit from here. Then the tree will be something like, is that actually easier? So you have commits, right? So if you have a branch from here, then what you can do is you can create another commit called merge commit here. Then the tree will keep this way. So the tree will be this. So you have a divergence and come back to the main branch. But if you do a fast forward, it will be, even though you have this, then these two will be moved to here. So you have a much cleaner tree. It's easier for you to go back to time. But if you are still confused, you can just do some Googling. Google is your best friend. So if I do a git fetch